Let's now determine the average value of the function f of x equals x squared minus 2x defined over the interval 0, comma 3. So here we are going to use the definition of the average value of the function, that is average value of function f of x defined in the interval a comma b, and this equals f average, that is f of average value of the function equals 1 over b minus a integral of a to b f of x dx. So we will be using this formula to determine the average value of this function. So let's use this formula to determine the average value of this function f of x. So first we determine the a and b. So we see that a equals 0 and b equals 3. So let me write down f average, and this equals 1 over b minus a, which is 3 minus 0 multiplied with integral of a to b, that is 0 to 3. So these are the limits of this integral, and then f of x. So let me replace f of x, which is x squared minus 2x. So now we have to integrate this expression within the limits 0 to 3. So let's simplify this. 3 minus 0 is 3. So therefore this becomes 1 over 3, integral of 0 to 3. So here we can integrate each terms one by one. So when we integrate this x squared using the power rule of integration, that is if we have the term x raised to the power of integral x raised to the power of n, and we have to integrate this, the formula is x raised to the power of n plus 1 divided by n plus 1. And then we have this integration constant. So here it is a definite integral, so we don't need to put the integration constant. So when we apply the formula, that is this formula to this term x squared, we can write down this integral as x raised to the power of 2 plus 1 divided by 2 plus 1 minus of we have the constant 2 and we have to integrate only the x. So once again we can use this same formula. So we consider x as x raised to the power of 1. So therefore this becomes, when we use this formula, 1 plus 1 divided by 1 plus 1, and we have to evaluate this expression within the limits 0 to 3. So let's simplify and evaluate this integral value. So therefore this equals 1/3, and x raised to the power of 2 plus 1 is x power 3 divided by the same number x power 3, and then this becomes 2 times of x raised to the power 1 plus 1 is x raised to the power of 2 divided by 2. So we can cancel these 2's as like this, and this has to be evaluated within the limit 0 to 3. So now let's apply the upper limit as well as the lower limit. So when we do that, we get 1/3 of, we applied the upper limit 3. So therefore this becomes 3 cubed by 3 minus of this is x squared. So it becomes 3 squared, and we put minus, and then we apply the lower limit. So when we apply the lower limit, we will get 0 cubed by 3 minus of 0 squared. So basically this quantity is 0. So you can just ignore it. So now this simplifies to, this becomes 1/3, and we can cancel this power. This is 3 power 3, and this is 3 power 1. So we just have to subtract the powers. When we do that, we get this as a 3 square. So 3 square is 9, and this is also 3 square, which is 9, and 9 minus 9 is 0. So therefore it becomes 1/3 of 0, which is equal to 0. So this is the average value of the function. Let's now determine the average value of the function f of x equals cos x plus 1 defined in the interval 0 to pi by 2. So once again we determine a, this is a equals 0 and b equals pi by 2. So let's utilize this average value function formula, that is f average, and this equals 1 over b minus a, which is pi by 2 minus a is 0, and integral of a to b, that is I'm sorry, it is 0 here. So a is 0 and b is pi by 2. So it is between the integral 0 to pi by 2, integral of f of x dx. So I put the expression for x of x, that is cos x plus 1 times of dx. So now we simplify this. So the reciprocal of 1 over pi by 2 is 2 over pi. And then we can integrate this as term by term. So integration of cos x is sin x, and integration of 1 is x. So I put x over here, and this has to be evaluated within the limits 0 to pi by 2. So let's substitute the upper integral and the lower integral. So therefore this becomes 2 over pi sine of pi by 2 when I apply the upper integral, plus I replace x by pi by 2, so it becomes pi by 2, minus of sine of, I apply the lower limit now, so sine of 0 plus x is replaced as 0. Sine 0 is 0, and this is 0. So we can see that this evaluates to 2 by pi. The value of sine pi by 2 is 1. So therefore this becomes 1 plus pi by 2. Now let's distribute this 2 by pi into the terms inside the brackets. So this becomes 2 by pi times of 1 is 2 by pi, plus 2 by pi times of pi by 2. And this gets cancelled, these terms gets cancelled. So it's basically 1. So therefore the average value of this function is 2 by pi plus 1. In part C, we have f of x equals root x. So let's determine the average value of this function. So here a equals 1 and b equals 9. So therefore f average, and this equals 1 over b minus a, that is 9 minus 1, integral of a to b, that is 1 to 9, f of x dx, that is f of x is root x dx. So we have to integrate root x within the limit of 1 to 9. And so here we have 1 by 9 minus 1 is 8. And we can write this root x as x raised to the power of 1 by 2 dx. This has to be integrated within the limits 1 to 9. Now we can integrate this using this formula, that is integral of x raised to the power of n dx is x raised to the power of n plus 1 divided by n plus 1. So here n equal to half. So when we use the formula, we will get 1 by 8 x raised to the power of 1 by 2 plus 1 divided by the same number, that is 1 by 2 plus 1. And this has to be evaluated within the limits of 1 to 9. So let's simplify and evaluate this. So this equals 1 by 8. 1 by 2 plus 1, and this equals 1 by 2 plus 2 by 2. This equals 3 by 2. So basically this is x raised to the power of 3 by 2 divided by 3 by 2. This has to be evaluated from 1 to 9. Now let's simplify this. So this equals 1 by 8 times of, I'm going to take the reciprocal and multiply. So this becomes 2/3, and then evaluate the expression x raised to the power of 3 by 2 from 1 to 9. So this gets simplified as 1 over 12. And I can rewrite this x raised to the power of 3 by 2 as x raised to the power of 1 by 2 raised to the power of 3. This is according to the exponents law. We know that x raised to the power of half is root x. So root x cube. So this equals, we have to multiply root x itself by 3 times. So root x times root x is x, and we then have root x. So basically this expression is equal to x times of root x, which I'm going to replace it here and evaluate within the limits 1 to 9. Now we can substitute the upper limit 9. So therefore this becomes 1 over 12, 9 times of root 9 minus of, when you apply the lower limit, it becomes 1 times of root 1. And this equals root 9 is 3. So it becomes 1 by 2, 9 times of 3 minus root 1 is 1. So 1 times of 1 is 1. So this becomes 9 times of 3 is 27 minus 1, and this equals 26. So it's basically 26. This is 26 over 12. This can be simplified by dividing by the common factor 2. So when you do that, we get 13 by 6. We can write down this as a fraction as this goes 2 times 2 1 by 6. So it's either 13 by 6 or 2 1 by 6. In part D, we have f of x equals 1 over x squared defined in the interval 1 comma 5. So here a equal to 1 and b equals 5. So let's determine the average value of this function. So f average, this equals 1 over b minus a, that is 5 minus 1, integral of 1 to 5, f of x dx, that is 1 over x squared dx. So first, I'm going to rewrite this expression, that is 1 over x squared as x raised to the power of negative 1. So therefore, this becomes 1 by 5 minus 1 is 4, and this will become 1 to 5. I'm going to write this as x raised to the power of negative 2 dx. Now we can use this formula, that is the power formula of integration. So therefore, when we integrate x raised to the power of minus 2, we get x raised to the power of negative 2 plus 1 divided by the same number, that is negative 2 plus 1, and this has to be evaluated from 1 to 5. So let's get this simplified. So this equals 1/4 of x raised to the power of negative 2 plus 1 is negative 1 divided by the same number, negative 1, within the limits 1 to 5. So now we multiply 1 times 4, I'm sorry, negative 1 times 4 is negative 1. So I put this as negative 1/4 times of x raised to the power of negative 1. This I write down this as 1 over x. This has to be evaluated from 1 to 5. Now let's apply the upper limit. So therefore this becomes 1/4 times of 1/5 minus of 1 by 1. And so this equals negative 1 by 4. 1/5 minus 1. We will simplify this. This is 1/5 and this is 5/5. So this is 1 minus 5 by 5, which equals negative 4 by 5. So I put negative 4 by 5 here. We see that negative times negative is positive, and this 4 gets cancelled, so it is 1/5. So this is the average value of the function. We now do part E. So here a equals 0 and b equals 2. So therefore f average, this equals 1 by b minus a, which is 2 minus 0, integral of 0 to 2 f of x dx, that is x times of square root of x squared plus 1 dx. So it is 1 by 2 minus 0 is 2. This equals 1 by 2, integral of 0 to 2 x times of x squared plus 1 under the root dx. So here I'm going to use the substitution method. That is, I'm going to substitute x squared plus 1 equals t. So therefore it becomes x plus, x squared. Let me rewrite this. This is x squared plus 1 equal to t. Now I take differentiation on both sides. So differentiation of x squared is, when you use the power rule, we have 2x. We also put dx, and differentiation of 1 is 0, so it becomes 0. And this side, when you take differential for t, it is 2t. So basically we can find this expression, that is x dx. This equals dt over 2. Now, since we have utilized this substitution, that is, we are actually converting this integral into t variable. And this means that the limits that we have now are the limits of x, that is, this is x equal to 0, and here this is x equal to 2. So these two limits has to be converted to t values. So for that, what I do is I substitute x equal to 0 into this expression or into the substitution. So I get the corresponding value of t. So let's do that. That is, when x equal to 0, when you plug x equal to 0 into x squared plus 1, becomes 0 squared plus 1 equals t. So this implies 0 squared is 0 and t equal to 1. So when x equal to 0, the value of t equal to 1. And similarly, we will find the corresponding value of t when x equal to 2 by substituting into this substitution. That is, when x equal to 2, this becomes 2 squared plus 1, and this equals 2. I'm sorry, t. So therefore, this gives 2 squared is 4, 4 plus 1 is 5. So we get t equal to 5. So therefore, now we can see that when we apply this substitution, let me rewrite this integral which we have currently. That is, we have 1 over 2, and the limits of x are, that is, x equal to 0 to x equal to 2, and then we have x times of x squared plus 1 under the root dx. So when we convert this into the t variable after we did the substitution, this 1 by 2 will remain as it is, and the limits of x will become limits of t, that is t equal to 1 to t equal to 5. So therefore I put 1 in the lower limit and 5 in the upper limit. Now we see that we can replace this expression, that is x times of dx, we can replace this as dt over 2. So I'm going to put dt over 2, and we already made the substitution, that is x squared plus 1 equals t. So therefore this expression under the root, this is replaced as t, so it becomes under the root t. So now we have converted everything into the t variable, from x variable to the t variable. So we just have to focus only on this integral. Let me multiply the numbers. This 2 times 2 is 4, so it becomes 1/4. So basically we have to integrate from 1 to 5 root t. Now let me rewrite this root t as t power 1 by 2. So this becomes t raised to the power of 1 by 2 dt. So it's basically we have to integrate only t power 1 by 2, which we can integrate using the power rule. So when we do that, we get 1/4 of t raised to the power of 1 by 2 plus 1. We have to put 1 by 2 plus 1, which is 3 by 2, and divided by the same number, which is 3 by 2. And this has to be evaluated from 1 to, this is actually 5, so 1 to 5. Now let's find an easy way of substituting this. T power 3 by 2, this is equivalent to t power 1 by 2 power 3. And t power 1 by 2, we know that it is root t. So we are basically finding the cube of root t. So this equals root 2 times root t times root t times 3 times. So root 2 times root 2 is t, and this is root t. So this is the simplified expression which I'm going to place here. I'm also going to multiply by the reciprocal of this 3 by 2. So therefore this becomes 1 by 4 times of 2/3. And then we have t times of root t. This has to be evaluated from 1 to 5. So we can cancel this 4 with 2 as 2 times. So this becomes 1/6. 2 times 3 is 6. And we will substitute we'll apply the upper limit. So this becomes 5 times of root 5, minus when we apply the lower limit, it becomes 1 times of root 1. Root 1 is 1, and 1 times of 1 is 1. So when we apply the lower limit, we get the value as 1. So this is the final expression, or the final value, that is the average value of the function. We now find the average value of the function f of x equals 2 sin x cos x in the interval pi by 6 to pi by 3. So here we have a equals pi by 6 and b equals pi by 3. So therefore f average, this equals 1 over b minus a, that is 1 over pi by 3 minus pi by 6, and integrated within the limits a to b, that is pi by 6 to pi by 3, f of x dx, that is 2 sin x cos x dx. So first let's simplify this. So this equals pi by 3 minus pi by 6. I can rewrite this as this is the first term. This is 2 pi by 6 minus pi by 6. And so this equals 2 pi minus pi is pi. So this is finally pi by 6. So I'm going to put 1 over pi by 6 integral from pi by 6 to pi by 3. I'm also going to rewrite this expression 2 sin x cos x using the double angle identity for sin x. That is, we have the double angle identity, that is sine of 2x this equals 2 sin x cos x. So therefore, we can write 2 sin x cos x as simply as sine 2x. So let me put sine 2x, then we have dx. So it's basically we just have to integrate this expression sine of 2x within the limits pi by 6 to pi by 3. So let's continue. So therefore this becomes, we put the reciprocal of pi by 6, which is 6 by pi. And when we integrate sine 2x, we will get negative cos 2x divided by the differential of 2x. The differential of 2x with respect to x is 2. So we put 2 here, and this has to be evaluated from pi by 6 to pi by 3. Now let's multiply the numbers. That is, we can cancel this 6 with 2 as 3 times. And we also have negative. So I multiply this negative with 3. So therefore this becomes negative of 3 over pi. And we have to evaluate cos 2x within the limits of pi by 6 to pi by 3. So let's apply the upper limit. So therefore this becomes negative of 3 by pi. When we apply the upper limit, that is pi by 3, we will get cos of 2 times of pi by 3 minus, when we apply the lower limit, cos of 2 times of pi by 6. So this equals, we have negative 3 by pi, and this is cos 2 times of pi by 3 is cos 2 pi by 3 minus, can cancel this 6 with the 2 as 3 times, negative of cos of pi by 3. Let's evaluate the value of cos of 2 pi by 3. So I'm going to do it separately over here. That is cos of 2 pi by 3. This I can rewrite in terms of reference angle combination. That is cos of pi minus of pi by 3. And this is the reference angle. Since it is pi minus pi by 3, this angle actually lies in second quadrant. In second quadrant, cos is negative. So therefore, we say that negative of cos of this reference angle, that is pi by 3. And we know that cos pi by 3, which we convert to degrees, it is cos of 60 degree. Cos 60 degree is half. So therefore, this becomes negative half. So the value of cos of 2 pi by 3 is negative half, which we will substitute here. So we have negative 3 by pi, and inside we have negative half minus, we already know the value of cos of pi by 3, which is half. So this becomes negative half. So this will result in negative 3 by pi, and negative half is actually negative 1. So negative 3 times negative 1 is positive 3, and divided by pi. So therefore, this is the average value of the function. So we have determined the average value of the functions given in parts A to F.